Problem 2 of the AB 2017 FRQ, and we have that F here measures the rate at which bananas are being bought at a store, and therefore the rate at which bananas are removed from the store, and then G measures the rate at which bananas are being added to the store, and G starts at T equals 3 hours, F starts at T equals 0 hours. The store already had 50 pounds of banana on display at time T equals 0. And also, we know in summary that F subtracts, G adds, right? Okay, cool. And F is the rate at which bananas are being removed. Okay, cool. So in part A, it says how many pounds of bananas are removed in the first 2 hours that this store is open. Since F measures the rate at which bananas are being removed, we know that all we have to do is integrate from 0 to 2, the function f of t dt, and this we do using our TI-89 calculator. From F3 we select integrate, and then the syntax is what I'm about to display, but because I have videos dedicated to TI-89 calculator skills, I'm not going to talk about like the syntax in detail. You could just watch one of my TI-89 calculator videos, and I'll try to link the right one under each one of these videos. Anyway, here it is. And one important note is, look, I got a slightly different but incorrect answer the first time I tried it, and that's because I was in degree mode. So to get the correct answer here, you have to be in radian mode. The correct answer is right here. Notice that this answer right here is wrong to 3 decimal places. So if you put that as your answer on your AP exam, then you'll get it wrong. And so be careful of which mode you're in. Yeah? Okay, cool. So that's part A. And then part B is, let's see. Part B is this, right? Which is, part B is find f prime of 7. Using correct units, explain the meaning of f prime of 7 in the context of this problem. So, f prime I find by using the TI-89 calculator. So, first, I already knew that I typed f, and so I could save myself some time if I like copy and paste the function f from like having had to type it in part A. But yeah, here's what I did. So I copied and pasted it into the function differentiate, which you get from F3 and then selecting differentiate, and it comes with a D and an open parenthesis. So I pasted the function f into that, and then I followed the correct syntax otherwise, which is just comma x. And when I did, it showed me the derivative right here. I noticed that it didn't finish displaying it as that arrow shows there. But I didn't care. All I did is move my cursor to what I've circled here, which is the derivative. And then I copied and pasted it. This time, I pasted it under y equals. And you'll see why I wanted to do that. So that'll look like this. So when I pasted f prime under y equals under y1, I got this. And so then I did the same little trick I taught you in the solution to problem 1 of the 2017 AB and BC FRQs, which is once you have a function typed under y equals, then from your home screen you can call on it. So I went to the home screen and I typed y1 of 7, and my calculator knew to go to y equals and then go to y1 and evaluate that function at 7. And when I did, I get this value. Now, to finish part B, we need to interpret this value. And it's saying, this value is saying that the rate at which bananas are being removed is decreasing by 8.11954 pounds of bananas per hour. Because remember, F measures the rate at which bananas are being removed, and f prime is the rate at which f changes. So it's since f is measured in pounds of bananas per hour, so pounds per hour, F prime has to be measured in pounds per hour. Yeah? Okay, cool. All right, so let's move to part C then. And what does that say? Let's see. So that says, part C says this, which is the number of pounds of banana on the display table increasing or decreasing at time t equals 5? Give a reason for your answer. Well, this at time t equals 5, this is measuring the rate at which bananas are being added. This is measuring the rate at which bananas are being removed. And so if we did g of t minus f of t, then this tells us the net rate of change of bananas, right? Like this is the net rate of change of bananas. And so this is what we'd like to decide if it's negative or positive, this quantity here, but specifically at t equals 5. So we do g of 5 minus f of 5 and look at its value. And if it's less than 0, then we say that the number of pounds of banana on display is decreasing at that time t equals 5 hours, right? So if this is less than 0, and of course I say less than 0 because I know the answer, right? And so we decide using the TI-89 if it's less than 0 or greater than 0, and here's how. So first, I went to y equals, and I typed f under y1 and then g under y2, and then remember f subtracts and g adds. So I needed to do g minus f, so I needed to remember to go to my home screen and ask for the difference between the value of g at 5 and the value of f at 5. But I had to lead with g, and that means doing y2 of 5 minus y1 of 5. Remember, I typed g under y2. So y2 of 5 minus y1 of 5. I don't know why this one requires so much. Yeah. Anyway, yeah, there you go. And when I do, I get a negative value, and that's the negative value that is g of 5 minus f of 5. So you write that down, this number, and then you say, since it's negative, it means that the number of bananas on display is decreasing. Yeah, because again, g of t minus f of t is measuring the net rate of change of bananas. Yeah, are bananas being removed or being added, right? That's what I mean by that. Okay, cool. All right, so let's see. Part D is all we need then, right? Okay, so let me get rid of this and display part D. I stuttered a little in part C, so like I'm like now like thinking, do I re-record? Do I not re-record? I think like I'm not gonna re-record. I've already re-recorded this one too many times. Anyway, here we are. Part D. Part D says, and it's pretty straightforward. It says, how many pounds of bananas are on display at time t equals 8? Well, we know that we started with 50 pounds of bananas, so we start with that, 50 to start, and then starting with time t equals 3, we started adding at a rate measured by g. So to figure out how many bananas in total we've added since g started, which is starting at 3, we just need to do the integral from 3 to 8 of g of t dt. And then we subtract all the bananas which are removed, and they're removed at a rate measured by f, and they started being removed at 0, so 0 to 8 of f of t dt. Whatever number we get out of this, that's how many bananas we have at the end of 8 hours. Yeah? Okay, cool. And of course, surprise, surprise, I did all this using the TI-89, and here it is. And if you do all that, then you get the answer 23.3474. Man, if I had a share of this banana or these bananas, I only want the decimal part. I want 0.3474 bananas. Yeah, okay, cool. Keep watching. Take care.